Welcome everybody. So my name is Ibrahim and we will talk about multi-master replication or multi-primary replication and how we can achieve that in PostgreSQL and what kind of solutions are available in PostgreSQL and how we can use that. So we will discuss about that. Before going to the multi-master replication, we need to understand what is the replication. And what kind of replication is available in Postgres. So when we are talking about the replication means you replicate your data to another server. Or you have one primary server and you want to replicate or duplicate your data to another server. So in that case, if you replicate your data, so you have two nodes, so you can read from other nodes. So we will discuss that. We can write it or not. When we can write it, that's a multi-master. But currently we are discussing in PostgreSQL, there is a one primary server and you replicate your data to another server, and you can read from both the server and write to different. So that's a single primary server. So what kind of replication available in PostgreSQL? PostgreSQL have two kinds of replication: physical replication and a logical replication. So we will discuss what is a physical replication and what is the logical replication and which replication is good for the multi-master replication and how we can achieve that and what tools, solution, platforms available to achieve that. So replication use case. So why we need, the first question is why we need replication. If we have one server and we can write data, why we need multiple servers that we can read data? The first one is a high availability. The major first goal is the high availability. That is, your one server fails, you have the replicated data. So data is continuously replicated to another server, so you can use your replication server. So second, data retention. So you can have multiple nodes, multiple replicas, so you can read any replica. So you can achieve low data retention. Data residency and zero downtime, load balancing, data migration, ETLs, data warehousing. So these are some use cases of replication. I'm not talking about the multi-master replication. Multi-master replication enhance these thing, but at least when we're talking about the replication, so that's the benefit and the use case of the replication. So first in the physical replication, what is the physical replication? Physical replication is when you replicate your own node, when I'm calling the cluster, the whole PostgreSQL node to another server. So it's a block-wise replication. So you are transferring your wall to the other server and applying that block, and it's a block. So in PostgreSQL, you have one primary. You can see this one is the primary one. It has in this node, you can read and write to that, and that's called your primary node. And primary node always have a walls files. So it put that wall files into PG_wall directory in your data directory. PostgreSQL has its own data directory where its all data resides. So PG_wall has all the walls in the PG_wall directory. So there is a wall sender process. When you start your PostgreSQL, there is a process called PostgreSQL checkpointer, and it's a wall sender process. You can check there is a wall sender process. And what is the responsibility of wall sender? Wall sender will send the wall to the other computer, another node. So you can specify where you want to send that. So you can configure that in the PostgreSQL not. Right. So your wall sender process will send your walls. So you have replica. So you have a replica that's called a read node, or replica, a slave, a standby, whatever you want to call it. This is also a slave node. So in that node, there is a process called wall receiver. So wall receiver will receive your wall and apply that wall on the replica. That's called a physical application. What is the benefit? Real-time transfer of walls. So you can just write on your primary and you can read from your little bit of delay, but you can read that from your replica. So it not only replicate, it also act like your standby server. So when your primary fails, this becomes your primary. So now when this becomes primary, you can read and write them directly. But before that, you can only read that. Then it's a slave, standby, or replica. So it is, it can be a synchronous, but asynchronous. It's depending on the configuration. We can discuss the according synchronous and asynchronous application. We will discuss in a minute. PostgreSQL physical application also provides the failover. I told you about that. That's a failover that if your primary node fails, your secondary node become a primary node, and that's called a failover. But it doesn't provide your auto failover. You have to promote your slave replica node to the parent. That's a manual process. But you can automate it. It provides you a way to automate that. But you have to do that yourself. Because it has some problem. We will discuss that what kind of a problem, why it's not promoting itself. Just an example, if there are 3-4 replicas, which one will become the primary? If it's automate process, which one will be the primary one? So it needs some kind of a forum, an action should be happen there. So there is no mechanism available in PostgreSQL, but outside the PostgreSQL, you can achieve that. In physical application, there is a concept of asynchronous application. In asynchronous application, you have a client, you have a primary, you have a secondary, you have two secondary and one primary. Just for an example, you can have many secondaries, it doesn't matter. So when you write something and this write on primary, and you will get the reply that write is done. Okay, write is done. And underneath, the primary send that to the replica. And similar, primary send that to replica 2. So it will get the reply afterward. So what is the benefit of that? The benefit of that is speed. Because when you write it, you will get the primary, write the data, that's okay, you will get the result. But your replica will be updated soon. Not right now, but soon. After that, after you get the reply, it will get replicated. So that's about asynchronous. And that's the basic concept of asynchronous, where we don't have to wait that your write is done on the replica. That's called asynchronous. And the similar is synchronous application. So in synchronous application, your client write to the primary and wait that all the data is written back to their replicas. So it will write to the first replica, wait for the second replica, and then it's write to the replica 2 and wait for the replica. And it's possible that you can get the response from replica 1 and you get that response to the get back response to the primary. But there is a forum kind of a bit in time that you get only one response that all the replicas got that message, got that transaction, got that data. So you can get one message, not all message. If you see in the previous screen, you are getting multiple, got it. So here you get it correct commit, and then you get the right complete for all of the replicas. Here, now we are moving towards our multi-master application. PostgreSQL physical application, multi-master application is not possible. We discussed that what's the physical application. We discussed what is the synchronous and asynchronous application. But we can't achieve a multi-master application using a physical application. So there is another application in PostgreSQL that's called a logical application. And logical application means you logically replicate your data. That means its granularity level is not the whole cluster. Your granularity level is a table level. So you can replicate on only one table. That's a benefit. You can replicate your whole database. You can replicate on your whole cluster, but you have to configure it. So you have the multiple levels, so logical levels like whole cluster, database, table, so you can replicate that. So that's called a logical replication. How logical replication works is called a publication and subscription model. So in publication and subscription model, your primary make clear in your mind that there is no primary and there is no replica in this kind of an application. The both are the same. There are two independent PostgreSQL servers, right? Two independent PostgreSQL servers, and what server there is. I already told there is the war thread where the war files are there, and there is a logical decoder. So when you write something and it goes to PD1, and if you configure that this node is as a publication on that table, so logical decoder will decode that and send that to the other. And another node subscribe to that table. Subscribe to that table. That I will receive that and I will apply it. So you will get the changes from the publication and you apply that on the subscription. So that's publication and subscription model is used in a logical replication. So that can be other way around. That's interesting. So here we go to the multi-master replication. That same table can be a publisher in this site and subscriber in this site. What that is mean? If I specify a database of publisher in this side and subscriber for on this side too, and publication in this side and subscriber in this side. So I can do a multi-replication. But we will discuss how. Before going to the other detail of the logical replication and multi-master replication, there is some concept you need to understand. So how logical replication works, because that's very important. That's a bit technical, but I try to bring more user-specific detail in that slide so you can cover that. So Postgres has a logical slot, and logical replication slot is what assistant replication by retaining changes until confirmed by all the subscribers. So, for example, you have a replication slot in a publication, and you have a publisher. You have published. This publisher have a logical slot, and it's published to 2 or 3 subscribers. Until all the subscription apply that changes, it will retain the bond. That's possible. That the bonds are in PG bond, and when the publisher start publishing your data, the bond that will reset or deleted. And maybe your subscription is down. Your computer is down at that time. Maybe 10 minutes, 15 minutes is down.
Question for you. Who was relative logical replication? I understand that the data is decoded.
Yes.
Where's the decoded data stored? Is that persistent anywhere, or is that just in memory?
Yeah, it's memory.
If the memory still present. So if something happens, then it'll get and you restart replication, it will get reinstantiated. Then when you
and that's where the logical replication slots work.
Yeah.
So logical slots, you have a logical slot. If data is not on the subscription side, it's not confined to the subscription. The was still living. It will catch up.
Yeah, and the decode happens again.
Yeah, but again. Okay. All right, great. So that's the logical replication. If I told you that if one subscription, if you go back to this state, if this machine is down, for 10 minutes, 15 minutes, so then your wall will be recycled here. Because there is a recycle time, you can't retain your wall forever on that computer. So it can be recycled. But if it has a publication and have a subscriber, so it will retain the wall because of that logical replications. The slot thing is that it will wait, the subscription will come up and catch up. So when it catch up, then it can recycle that wall. That's important. So that one logical replication slots is very important in that case. So I told you it's a very critical that your logical slots are there, because if your systems are down, the system is down, and again come up, and you have to catch up. In physical replication, you can also catch up. There is other mechanism, but it's not topic of today's. So, but in a logical, you can catch up with that. It does. So there are some monitoring tools that can see what are the other slots are available, how you can look at the slots, what the condition of slots. So you can see that it is a select static from 3D stack replication. There is a view you can set. Just for information that these slides will be available on PTN site. So you can go and download. So all these slides will be available from. So don't worry about that. So you can always delete this slide and replication slot. Why do you need to delete? Sometimes your subscription is down and never come. So why you need to retain your wall for forever? Because if your subscription is down, your wall is counted. So you need to delete that wall. How you to delete it? You can't go and write RM-RM and that's your wall. You can't delete that because some are useful walls are there. So you just do that. Your subscription is finished. Everything is finished. You don't need that subscription anymore. So, perhaps you.
Sorry.
Yeah. Related question. Where is that information is stored? Like, okay, this subscription, mapping of subscription versus wall.
Next. Not the slot. Actually, it's technically.
Slot versus wall file.
Yeah, coming. Next slide. So we will create some publication and subscription. We will create. Basically, these all the information are saved in PGCat, the catalog of Postgres. There is a catalog, all the publication, subscription, the catalogs are available. So all the information are stored in catalog, like the table information.
This back.
So for the logical application, your PostgreSQL should be configured logical. One level should be logical. Otherwise, you can't create a publication and subscription. So you have to set logical. So set one level to logical in PostgreSQL.com. Max application slot. You can specify how many replication slots you want. So you configure that and max wall center. So you can specify according to your need how many you need that. So I just said that vertical 4 slots for wall singer. So just for the example here. So how will we create a publication? So just create publication, my publication for all tables. Just for example. Okay. So create publication for table 1, table 2, table 3, table 4. I want to create a publication for these tables. So I just create the publication and it will create underneath the whole system context. So here, that's important. Because publication is just will stand the wall. That's it. Publication is that I am publishing these. It's like it's a proof form, but I say that the publication means it is just throwing the table in the environment. And anybody who needs that table subscribes to that. So he will get that. Not everybody needs that table. So who needs that table will subscribe that table. So you will get that information and apply. It's like that. So create subscription, my subscription connection goes so on the T2, the primary one, not primary one, the publisher one, the port, DB name, user, password, publication, my page. That's it. So now this subscription will subscribe to that publication. What's that the publication? The publication maybe this one, maybe this. You can't create both the same name. It's just an example that for all table and this. So my publication if this is my replication, the all table will subscribe to the description. For this one, table 1 and table 2 will be subscribed for version.
It's not so that still the team is first.
Yeah.
So for example, you have like, of course, different name of both command. You run both command. In that case, you created publication 2 times for table 1 and table 2 in my publication 2 at maybe.
Oh, no, either way. You can't run these both.
So
The name is same.
no, I say, for example, my first one is not naming my publication 1, second one my publication 2. Can I run both command?
It can use the bank, but it doesn't matter because it will publish the only one time. It's not published the 2 times because it's a wall.
Right. So microservice is like when we are saying all tables in first one, table 1 and table 2 will be included in that
Automatic. Yes. Because it's all table.
on table.
Like static. This one is like static.
Right. That is only table 1 and table 2. Second one.
Second one is only one.
Only table 1.
Yeah.
Is there any way to exclude, like for example, I have 100 tables and I don't want to create one publication for all.
No, actually, this that's in word static. You can that exclude table 1 and 2 table. No, there's no X.
Not like
Yeah, like if you want to have 98 table and not 2 1, so write 98.
4 out or excluding 2.
Excluding 2, you want to exclude it 2, no, that's and
saying that, okay, and golden gate,
yeah, you have to write 98 something. So
I think
I just will script you just.
I have asked you management part of you, like if you have 100 tables and then later you added 10 more tables, then how you manage, like it is kind of a lot of overhead on maintenance. Why that?
Actually, usually people do that using the scripts and something like that, not manually. Not manually, just get the tables, which names are not like that, something like that. They query that and put that into the subscription and publication space.
Like,
Yep, not a thing. So, we studied release an application. Yes.
So, in the subscription, we didn't define the slot. Am I right? Does it really need an application slot?
No, actually, under it, everything is created with the same name or something. No? You can create your own slots, but if you create a publication and set effect, it will create its slots for you. But you can manage it because sometimes I let you know in next slide where you need it. No, normally you don't need it because it automatically created for you.
That's
But when you need it, I will tell you where you need it.
that's
and you need to have the table set up on the subscriber before you can subscribe, or will it create table swag?
No, you have to get it. Table should be already created.
it should be clear.
Should be. Table should be on the author side.
Is there any schema validation when you do a subscription to make sure there
No.
Okay.
Actually, the schema validation is in even the schema curve. I will go back to for your first term. Then just in logical application, only DFL will be replicated, not the DTL. If you create table, it won't create the table on the other side. Even that's the publisher and the subscriber are there. It will give you the error when you create subscription to it. Then no table name, table 1 and table 2. You have to create it yourself. So DTL is not logically replicated. You need or don't.
So when you have those schema differences, the publisher and the subscriber, are there any catalog tables to look at the failures, the reason of the failures? That, let's say like
Postgres log file, you can see the errors. In the Postgres log file, you can see the errors that these are not the compatible, the error, what kind of error. Because it's a similar error that you have this. That's a similar error. Like you have a table and that you want to insert different data on that, it is not compatible. You will get the error. So here, when it's coming from the replication side, the same error, but in the Postgres log file. So continuously see that try to insert the data, but the data type is not compatible, continuously giving you the error. So you have to look at that yourself.
So the failures should be seen on the subscriber. The publisher is not able to.
No, publisher doesn't know actually. Publisher doesn't know your subscription schema. It will only generate the data based on publisher schema. That's it. Because it's like if I'm just broadcasting some information, so I don't know who is compatible with me. That's the subscriber responsibility to compatible with the provider. That's important.
So even if one table is broken, so the whole subscription will be broken, right?
Right, because it's in no section that's broken. Yeah. So, yeah.
So it's what the slot wants. So if you don't give it the slot, will it create a temporary slot or will it use a name slot?
Yeah, you need a name slot. It will create using the publication name.
Okay, so even if disguise, so it will work.
Yeah, it will remove it. Yes, it will automatically do that.
What will always make that? Like, no, with temporary slots, like,
No, that is a temporary slot. That's a permanent slot for the publication.
the slot is in order to come.
Is when you drop the publication, you drop that.
Dropping slot. That's it.
since for multiple subscription, which else in the rings for? Like, I mean, was let's say both the figures are in different state, like some service capturing one is already caught on. So like in the slot, which is there on primary, so which other thing, like, I was able to be like the supporter one.
It has its own image.
That's an honest.
So every subscription has different slot.
Yeah. When you create a publication, it's going to stop papers. So it will retain the data till that subscription is arrived.
First, continuation to that. So publisher, when you create it, start created.
Yeah.
There's no subscriber. And how does the publisher's instance would recycle or clean up that slot?
Because there is no active subscription, so it will clean up. So if there is any active subscription and it's not caught up, it will return. That's the if condition. So that's a so take up logical application common time 11, 12, 13, 14, 15. These are the Postgres what you can do in the PostgreSQL. So I don't think we can discuss that. It's just for the information. Actually, I put that because this feature comes in PostgreSQL 16, and this is very important. As the most highly and see that the many people ask this question. This problem is in production. That's a major goal. So everybody have that problem. So what is the problem? If you have physical application and you have a logical application both at the same time, it's not like that you have a physical application and that has some kind of logical information in that. So you will have a logical slot. And when your primary fails, secondary will catch up. So all your slot information will be lost. That's kind of a bug in Postgres. I call it a bug. So what then to me, you have a primary and you have a replica of that, physical replica. Your primary have a logical slots information too. Some slots are there and your primary fails. And your replica take over and become a primary. It has all the information, all the data, everything, except these slots in position. So slots are not. Slots are not replicated. So that's the biggest problem currently this production with the people are facing. In PostgreSQL 16, they provide a path which is called a minimum logical decoding. So I told you that your replica slave standby is read only, but they have one exception. They put one exception. You can create a slot there. In Postgres 16, 15, 14, you do that, create slot, it's a read only. You can't do that. But in Postgres 16, if you do create application slot, you can create it. So at least they give the opportunity to retain a slot. So what you need to do, when whatever application slots are the primary, get it? So create it on the replicas. There is no automatically available. Right? There are tools available. Like in BG, we have that setup. It's automatically replicated when logical is to start. But at least has the capability to do that. So when you create slots on primary, you have to create it on the secondaries at replicas too.
But does it update the lesson?
Yeah, everything they will have. Because it's doing the logical decoding. That's why I call a minimum logical. But it's doing as a logical decoding. But the payload slot to do just to that's what I said. They are external to the whatever. They're external to the but what they're doing, they are continuously reactionary primary, what slot, and they keep creating that on the replica. So the combo of that, or you can say PG at, we have that combo, so we are doing that. You have a PG failover slot with PG. And even PG at, we have backported that path to PG15 and PG14. So that capability is in PG 15.
So in 16, that means like this job we have the logical application between there, I get to me, and then in 16, and then since we can create the slot, that means from node B, we can have another node C, another target, because I can now create the application slot there.
Yeah, you can create that.
It doesn't need to be same name as what the name.
No,
But you cannot do the. Oh, you need to create again a publisher there to go, right?
not a public, you can't create actually.
Yeah, that's what I said. So
You're going to create a slot.
only the slot.
No, that's it. You can create slot, which I said. Same name, from same name to the primary.
But you cannot create any.
Publication, no, anyway.
So basically, you cannot go from node B to node C. If you want to scale them,
That's it. Not in vertical, but in a physical application, you can do that. Physical application and a cascade application, you can have as many applications. But that's in difference. So, actually, when I'm talking about you are mixing two things. In logical slots, you can have a cascade, but not mixed with the physical application. You have a publication, subscription, you have a publication, you have a subscription, you have a publication, you have a subscription. You can do that. But what is the benefit of that? Because it's already broadcasting. It's already broadcasting. The third one can also catch up. Okay. So there's no benefit of cascading in that case. But you can do that. You can do that. You can publish just keep in mind that anything you can publish it. And so whoever will catch. That's it.
the benefit of that, like, for example, node A is different, whatever Postgres one and node B is different.
Yeah, then node it one to the works to tell the course. It works. Only the schema should be the same. The table should be the same. The table structure should be the same. That at least it will be insertable.
Yeah, I have a question for the failover. When I failover from the primary to secondary, I created the same slots, the slots on the secondary with same name. And when I failover, the logical replication secondary can automatically connect to the stream replication secondary if I promote it to prime. But
Yeah, it
will start from
Same to same.
so.
Yeah, but I think he's asking you have a replication slot on the primary and you fail over to the secondary. So what will happen to the replication slot?
So replication slot won't replicate. Yeah. That's what I'm saying. Replication slots are not replicated in failover.
But in that case, how does the logical replication secondary catch up with the new prime?
That's what I was saying. Postgres 16 provide a way you can create a logical slot on the replica, even if it's a read only. But you can create.
So one discussion is pretty. When the publisher, you have some data which is being published, but subscriber had not caught up, means there is some data which is on the slot itself. And when a failover happens, this machine is gone, like, something happened to that machine. Okay. Cannot get the slot.
Yeah.
So you created a slot there, but the data which is not part of on the subscriber, what happens to that data is
Only subscription, the slots are not replicated. All the other information will be replicated to
the data will be replicated in one slot.
Information will be replicated except the replication slot. And we have created that. But it becomes the 100% same thing.
So what I need to do is just to create a slot on the secondary with same name.
That's it. That all other information will be there. So you don't have to worry about that.
So before PG 16, you should have a rewrite database to create an application. So
Yeah, right. RPG there was not RPG and both have testings. So I think we will go. We have we spend more time on the experience. Yeah. So active, standby, and active. That's single server and single server, multi-primary or multi-master application. So what is the one primary, multi-standby, one or more than one primary called multi-master. So we already discussed that. So I will come here because we discussed multi-master application. You have two masters. So you can write on both the servers. In a physical application, you have a master and slave. You can write only the master or the primary, and you can write on the replica or the stand. But if you have two separate computers and you have publisher of database here and subscriber of database here, and you have a same database publisher here and same database subscriber here. So that's multi-master because data is replicated. Whatever you write on node 1 will be replicated to node 2, and whatever you write to node 2 will be replicated to node 1. And that's called multi-master. But here are the problem. One thing, PostgreSQL does not support multi-master replication. They support logical replication. But we simulate multi-master replication using the logical replication. Because we have publisher and subscriber of one database here, we have a publication and subscriber of database here. So it's become a multi-master. There is no other connection between them, no physical replication, just the logical replication. But the problem is that both the side you are writing a different type of data. So what will happen on the table? Conflict. Because if you are updating a table in node 1 and something is inserting, deleting something on node 2, so fail, your transaction will fail. Continuously it doesn't fail because the conflict. The two activities are done on same table. So that's called conflict. So logical application does not handle conflict. Do not do conflict. So you have to do it yourself. That's the toughest part. That's why it's called, it does not support multi-master application. Limited, you can just go and detect that it's what have that. So you can do that, you can manage that, but you have to do it yourself. And application level, maybe you can achieve multi-master application like that. You have a table 1, and node 1 you are only writing to table 1, and node 2 you are only writing to table 2. So there is no conflict. But you are managing using the application. So you are not creating conflicts. So that's the solution. Then this multi-master application works, but you can't write on same table in the availability. You can't do that from multiple nodes. So what is the multi-master application? Simultaneously data netting on multiple nodes. Conflict resolution, it provides the conflict resolution. Load distribution, that's important. That's important because if you have one computer in US and one computer in Europe, and European people can write their data on Europe server, and US people can write their data to the US server, and data is automatically replicated between two US and Europe nodes. So that's benefit because your load is distributed. Improve fault tolerance, real-time data synchronization, geographical distribution. Okay, Europe and US we have geographically divide your servers all over the world, and they are all connected to each other, have a multi-master application. So you can read and write all the servers, and all the data is synced in the reads. Challenges: ensuring consistency across the multiple. Just for you to read further because I can't discuss this is the principle. Postgres architecture overview, We'll go some, first we already spent more time at the replication than that. So PGA, that's a spot with the extension at PostgreSQL. The PGA has wrote that extension, so you can install that extension. Where PGA has its own platform. Here you can have multi-master replication. Because I told you PostgreSQL, vanilla PostgreSQL does not support multi-master replication. You have to do that using the external tool. So Spot or PGA is the one solution for you. PGR, bi-direction replication, is second quarter now. It's open source, and now it's EDB's version 2, 3. They have their own closed source version of tags. So you can do this thing. And the PGX Spot is open source. You can go and download. You can from the PGX site. So that will the PostgreSQL Action is another solution, but it's not active right now. So, but people work on that, but it's not active project right now. So there are some other solutions too, but currently there are not many solutions for it. The main thing, what I told you in this presentation, that everything is done by the logical replication. They have not done anything magically. They use the logical replication and conflict resolution algorithms and make it happen. All other stuff also be done, so we'll discuss that. So, VDR, it's just for you to read. So, conflict resolution. That's important because in the multi-master application, conflict resolution is the main point. If you do want to do that yourself, do it. If you want to install PDR or PTR or Postgres or PostgreSQL, then they will do that for you. The loss type is. So, that's means if I write 2 in a table and write 3. So, whatever the loss will be committed. Right? Loss strings. Book will, data comes in the, for the write into the table will be committed. So, loss means version vector, utilize the version vector to keep track of the version history of the vacuum. So, that method allows the system to identify and resolve conflicts by comparing version histories and merge changes accordingly. Similarly, operational transformation. So, conflict-free replicated data, that's important. Because that's why. Because usually people have raw write chains. And the conflict-free replicated data and manual override. That's two all parts to important. Why? Conflict-free replicated data that you make a data structure like that the conflict won't occur. Like timestamp, something I've just given you two example, if you have all your sequence ID, timestamp, tag sequence. So you create a data structure like that, so you avoid the conflict. And the most true one, the manual override. When something happens, go to the computer and fix the conflict. So you have to dedicate one person, one computer, one database. So every time when there is a conflict, you just update that. So that's it. That's a big. So pros and cons. High availability. The multi-master application definitely is high available because if your write is down, you already have 2, 3. Because if you don't have a failover, doesn't matter because you have 2, 3 write nodes available for you. You can write on that, no problem. Geographical resiliency. So you can have multiple zones to install it. Scalable write. Definitely you can write with multiple nodes. Traffic distribution. You can distribute your traffic. A single master, you can only distribute your read load. You can only distribute your read load, not the write. But in the multi-master application, you can also distribute your write load. Complexity. Definitely multi-master application is complex. Because something happened, the debugging is really difficult. Alright? Conflict resolution. I told you, conflict resolution is another big problem. Manual intervention. Sometimes it happens that all the algorithms fail of conflict resolution. That it will create something application creates some separate table or view where you may see the conflicts, and the manual people will do that. But it's not too many. But if that algorithms fail, won't able to fix the conflict, that manual intervention is required. Data inconsistency. That if it's something happened bad, so maybe your data is in good system. So there should be some tool we should have capability to check the consistency of your data. Performance optimization. Definitely in performance optimization, conflict resolution is the main item. If it takes time, if it has a problem, that it's the performance sucks. Implement strict data consistency check. Definitely utilize efficient data distribution. That's most important. Your strategy, that where your right node go. I will tell you that, but you have 3 right nodes, and what is very common in Google that you can't read 5 heads of shaver. So if you have 3 computers and one is very big one, 2 are small. So you can't evenly distribute your right load. You can give more to your high-end computer and less to your server. So you have to, should we have a better balanced load balancers? So that's the final background of that. So high availability using what you say that physical application, logical application. So that's the big diagram of that. So here, the red one are your active node, the primary node, or you can say your right node. So you can write on your red ones. So the data is replicated all 3 nodes using the logical application. And all right node has 2 read nodes. So, and how? This is the physical application between the red one and the blue one. It is still need application. But in the between the red node, there is logical application because it's a multi-master application. So these are the single master application, this one. This is the physical. This red one is the multi-master application. And between here. It's like sync or simplex, the physical. Physical is a sync is better, but you can have a single sync. So, but sync is better in that case. So, but anything happen. So, this is also the whole infrastructure is available on GIAC. But the important thing is that there is 2-3 things that's the same. If I will give you again the logical decoding problem. This red node has the logical slot information. Okay. If this fails, because it's connected to the other system, so this will not know what is the information of this transits, because there is no logical slots there. It's not a bus. So what we are doing in a PG add or PG failover slots extension, what they are doing, they are continuously creating the slots information into the replicas. Continuously creating that. So whenever this fails, this has the information. It will become the red one. This will turn, this will become the red node. So it will continue in the replication. So that's it. Any question?
It was saying continue, creating a replication, like captation slot. But there should be some number. So like, we're going to find that doesn't mean continuously. Continuously mean when you create a slot on primary, it will detect that slot is created, it will create on the secondary. And that will continuously checking, not creating, continuously checking. If there is a new slot, create it.
About this last white green things, I was wondering, there could be some complexity when like node 1 start first, but probably wish the data was later. And also the nodes might have slightly different time. Is it the way to really actually, make sure that or stop that?
In logical application?
No, in the conflict resolution, or what you describe as like how you're going to figure out which update is either last. That's on trend.
Yeah, actually, there are multiple ways of that. Like sometimes they post the timestamp. Every row or every transaction have a timestamp in that. So it will go the timestamp, which was the latest timestamp, it will be committed.
Okay, certain.
So even you can say sequence numbers. A generic GID or sequence number is generated. So you pick that number, which has that written number, it will be counted. So there are multiple ways. But I told you, you have to do it yourself. Postgres doesn't provide that. So there you should use some tool which provides this kind of a mechanism. Like PGI, the BGR, the we have their version for that.
That's brief. So time zone on all the systems should be the same time zone. Right?
Yeah.
Yeah,
Otherwise, Postgres will convert that. You know that Postgres can you provide me Postgres the time zone is this, the correct time is this. So it automatically manages this.
I have one question. Can we have a sync process? Is it
Sync?
sync replication? Like async and sync, right?
This one physical.
No, this is a same region, right? Same region, different zone. Yeah, this is a source.
Yeah, it is.
Yes, the region, right? Yeah.
That's what.
Whatever the distance.
Yeah, look at that. The first thing is you have to check a link because you have this friend on your all client are connected to this one. So there's no problem. They will get the 1 minute. So they will get the real-time result here. So they will get the real-time result here. They will get the real-time result. If you don't have that, so if this client need to connect to this one, so definitely he has to wait. That's the benefit of the multi-master application. So thank you.